Hello everyone, my name is Dusan Stevanovic and I'm a vulnerability researcher at Trend Micro. So this talk will be about deserialization vulnerabilities, basically going into the description of the problem and then looking at some of the examples of vulnerabilities that I worked on over the last year and a half. So I'm a vulnerability researcher on a team called the Vulnerability Research Service. It's formerly known as TELUS Security Labs. We were part of, I've been on this team for 5.5 years. First 3 years we were in TELUS, and we are sometimes in the industry known as a TELUS Vulnerability Research team. However, over the last 2.5 years, almost 3 years now, we have been part of Trend Micro, and we are based out of the Trend Micro Toronto office, although right now we are working remotely. So prior to joining this team, I spent 8 years in graduate school. I did my master's and my PhD in computer science. My PhD focused on detection of DDoS attacks. I applied some machine learning techniques. I also did some analysis of browser behavior modeling to differentiate between malicious and benign traffic. My research was in security. However, it wasn't really related to vulnerability research. Although I spent a couple of months during my graduate school, my PhD, I actually worked as a penetration tester at a company, and I acquired some experience doing vulnerability research, and that's how I got into this field. I thought it was a very interesting line of work. So a little bit about Vulnerability Research Service. We are a leading provider of end-day vulnerability research as opposed to zero-day vulnerabilities. So we analyze vulnerabilities that have been already, advisory have been published about those vulnerabilities. Information has been released. Vendors have patched vulnerabilities. In some cases, we cover vulnerabilities that haven't been patched, but the Discover advisory, for example, has published a blog or a public POC. So we provide research reports and signatures for over 40 of the world top IPS, IDS vendors. Our reports, in our reports, we classify the vulnerability, we identify the version that's vulnerable, we go into the details of what the problem is and why there's a vulnerability. We identify the location code where the vulnerability occurs. We capture PCAPs, so we get the traffic. We develop detection guidance, write snort signatures if possible, and also provide proof of concept for exploitation so that our customers can verify how generate traffic or verify that this vulnerability is exploitable. So it's a lab-based analysis of known vulnerabilities based on reverse engineering. So this kind of service that we provide saves our customers time and the cost, because we pull everything together and we ship it to our customers, and they can include this threat intelligence into their IPS, IDS systems. So I decided to talk about data serialization. I've been working on some of these problems over the last, since I joined TELUS. But over the last few years, there have been more and more of these vulnerabilities being introduced. And the reason is that some of these memory corruption vulnerabilities that lead to code execution, there's a lot of mitigation that have been promoted by vendors to stop these kind of attacks. So it's getting more difficult to exploit these attacks. So researchers are going over the deserialization, trying to find the deserialization, insecure deserialization vulnerabilities, and which lead to code execution, arbitrary code execution. So it's a very serious kind of attack. So what is serialization? It's a way to take the structured data. So for example, in object-oriented languages, you have an object, you have each object has variables, and then you convert this object into a stream of bytes, and you can store it into a file, a database, or you can transfer it over the network from point A to point B. And deserialization is the process of, is the opposite process, taking the stream of bytes and converting it into an object. So the purpose of data serialization is for, like I said, remote or inter-process communication or caching and persistence. And the format, as we will see, there's a binary format that's used in Java and .NET, deserialization and serialization, Ruby and Python. There's also plain text deserialization of the, objects in the XML format, JSON, YML, and actually some of my examples will cover XML-based deserialization that I worked on recently. So so Java serialization are the most common types of attacks that we have seen, because serialization is used a lot in Java-based applications, and we've seen most of the serialization attacks in Java, although we also seen lately a lot of serialization attacks in .NET. So let's see an example. So here I'm showing how you would code serialization and deserialization in Java. So you have a myObject class and has two variables. One is a string variable, one is another object variable. So you use object output stream classes write object method to serialize the data of this myObject into a file object.scre. And the deserialization is the opposite. You're again using object input, using object input stream class by using the read object method for deserializing the data from the file into the memory. So Java objects that are serializable implement either a serializable or externalizable interface. If it's a serializable interface, then it's using you have to use read object and write object methods of object output stream. Otherwise, it's read externalizable and write externalizable methods of the externalizable interface that you implement. So there is some differences between serializable and externalizable interface. One is, I think, externalizable. You can it's for limiting what can be serialized and picking which data can be serialized and deserialized. But every Java serialized object starts with 4 magic bytes. And here I show the contents of this object.scre file that I showed in the previous slide. So you can see those 4 bytes. This is the contents of that file. So you see the first 4 bytes are the magic bytes. And you can also see the name of the classes in ASCII, and also the string variable. You can also be identified in the file as an ASCII. So when we look in our work, we are focused on identifying network-based vulnerabilities, so detecting network-based vulnerabilities. So we only look at deserialization attacks that can be conducted over the network. So sending serials out of the network in Java is very common. In HTTP requests, it can be the serialized object can be embedded in parameters, cookies, headers in the body of the HTTP request. RMI and JMX protocols are completely based on serialization. RMI has actually a well-known gadget chain, which can be used to exploit, although it has been patched recently. But it can be used to exploit deserialization attacks. We also looked in our research, we have worked on a lot of WebLogic T3 deserialization attacks, and lately they have been more and more discovered. I think even just this past October, Oracle patch has a couple of them. There's a SOAP requests can be used to transfer serialized object XML, and that's what I will show later in my examples. So insecure deserialization exploitation. Basically, like in other vulnerabilities, deserialization of untrusted input objects. Also, there's various gadget chains have been discovered in some of the Java libraries. They can be exploited, and we'll talk about those next. There's also look-ahead object types here that sometimes there have been mitigation techniques that have been introduced to try to minimize, to prevent these deserialization attacks, but sometimes they fail because objects, even if you were looking for a specific serialized object, that object can embed other objects in its variables. And you have to do a more hierarchical search to prevent those attacks. And we have seen these failed look-ahead object type checks in some of the vulnerabilities. So gadget chains. Java, they're called named Ysoserial gadget chains, based on the talk that was done in the beginning of 2015 by two guys where they identify deserialization vulnerabilities in Common Collection library. This library is widely used in many Java-based frameworks and applications from WebLogic, WebSphere, JBoss, and they've been discovered more over the last few years. This patch of this vulnerability only happened at the end of 2015, so nobody really took a lot of notice, even though this was, in a lot of these applications, it was unauthenticated, full-blown code execution attacks. So they named it Ysoserial in their talk. And let's look at some of the common collections gadget chains. So these are the gadget chains is a sequence of function calls that are made that eventually lead to arbitrary code execution. So for example, annotation, as shown here, when you're doing a read object, the read object can be overridden, and invocation handler, annotation invocation handler is a class that is present in the standard Java library. In its read object, it takes interface of map. However, map, a specific map implementation, lazy map, and also these other chain transform involved are part of the common collection library. So by actually initializing this annotation invocation handler with this specific map object, you can eventually lead to get to the runtime exec, which is a method that executes arbitrary code from a command line. So this, on the left side, I saw one of the command collection. There are actually 6 of them. On the right, I show another chain that leads to the same runtime.exec class. So I said there are 6 common collections, but over the years, there have been discovered many other libraries that are vulnerable, including bin utils, Commons file upload, Groovy, Spring, and many others. There's also for example, you can see on the left side, there's a JDK 7 update 21. So any application that uses an outdated or an old version of JDK standard library before this JDK 7 update 21 is vulnerable to arbitrary insecure deserialization attacks. But it doesn't even have to include any of the libraries, but just using the JDK, it can lead to code execution. On the right, I show some other ones that are based on the plain text deserialization, and I will talk actually about Extreme, another library in XML. So let's look at these examples. So over the last year and a half, I worked on 2 vulnerabilities in Apache Ofbiz application. It's an enterprise resource planning system based on J2E. There are 2 vulnerabilities here, one from last year, 2019, and one that was discovered over the summer. The 2 different web endpoints. This application uses web services, and 2 web services accept serialized input in 2 different formats. So let's look at one of them. Let's look at 2009 one. The problem here is that it's using Extreme, a library written in Java that allows you to serialize Java objects to and from XML data. So again, like we are taking an object, we convert it into a stream of bytes or plain text. So let's say here on the left side, I show an example person class that has 4 variables, 2 string variables and 2 variables of phone number class. And then you can see on the bottom left, you can see there's a person, how you would initialize this person class and how you would set these variables in that class. And on the right, I show how this would be represented in XML. And the Xstream library has an Xstream class, you can see on the bottom right corner, Xstream class that has 2 methods, toXML and fromXML. toXML takes the object and gives you back the string representation, the actual XML data. And fromXML takes this XML data and gives you back the object. So fromXML is for deserialization and toXML is serialization. So there's a gadget chain that can be used to generate these attacks. And the problem here lies in this HTTP engine class, in its HTTP engine method. It takes a request. As you can see on the left side, it retrieves the service context parameter. That service context parameter is expected to be XML serialized data. It also looks at does some other checks. It looks for the service name parameter also, must be present to continue in the code sequence, and then it takes this XML data, passes it to deserialize method in XML serializer. Eventually, as you can see on the right, this code reaches, this XML data reaches the Xstream from XML method, which takes the string without any input validation for what's allowed class. So the problem here is that this product uses some of the vulnerable versions of CommonsCollections libraries. So here I just show a GET request that you would send to this endpoint. So you can see there's a GET request and the URL is web tools control HTTP service. This URL maps to that method, HTTP engine in that class. You have the service name parameter and there's a service context parameter that it's equal to actual serialized XML object of bin utils, because the bin utils and file upload are the vulnerable versions. Vulnerable versions of these 2 libraries are included in this product at the time last year when this vulnerability was discovered. So here I show how it just a more clear example of how you would embed this bin utils payload in XML. So it shows how the XML is. So it's a very large XML that's when you generate it. So here I show now the video of the exploitation. So here I'm running from a attacker controlled server. I'm running my POC, and when I send the traffic, it pops a calculator, as you can see. So you can, it's an arbitrary code execution, unauthenticated. It's a serious attack. So another vulnerability in this product is uses XML RPC, which is a remote procedure protocol, which uses XML data to encode its calls and HTTP as a transfer mechanism. So it's basically invoking some method on the server. So here on the right, I show how you would encode, for example, if you're passing an array object, if you're passing primitive encoding, and also string objects. And on the right, I show like a struct has a members, and each member has a name value pairs. The problem with the name value pairs, as you can see, this XML RPC also accepts serialized object. So as you can see here, this is an XML description of this RPC call. You have a method name. As you can see, method name, there's a parameters, value pairs, and one of the values is a serializable element, a serializable element which encodes, is a base 64 encoded encoding of this object that's passed to them. So if you don't do any input validation, it can lead to arbitrary execution if you include some of those, for example, some of those vulnerable versions of CommonsCollections libraries, which this one does. This product does. So here I show that there's a class XML RPC request parser, which actually parses the XML data. There's a large sequence of method calls that are made, but what I want to show is that the actual vulnerability lies in this org.apache XML RPC.parser.serializable parser class. It has this get result method that's eventually called, and that's where the read object happens. So it takes the data and just deserializes it without any input validation. So again, I wanted to show here what happens when you send this POC. You get the code execution. You get the pop-up calculator on the target. So you can see we are running Apache Ofbiz 16.11.05. So the other vulnerability that I've looked at is in .NET serialization. .NET framework also utilizes serialization, deserialization extensively. It has XML serialization similar to what we have seen in Java, where you actually represented the object in XML format. There's a binary format which represents data in binary format, and some other formatters. There's also data remoting service protocol which uses deserialization, and it's susceptible to attack. So actually my example will focus on this remoting service that's present in one of the products that I looked into. So here on the right, I show, for example, we have similar to what I've shown in Java. Example, here you have a class, serializable class. It has two properties, and you're using XML serializer that calls serialize method. When you actually serialize this class, you end up with this XML on the bottom, this XML representation. And this is a binary format deserialization, which also calls the serialize method. So here the difference is in Java, some of these these classes use serialize method or even write object. So it's a little bit different than from Java, which uses only, that it's only the read object and write object. Nice. So here shows the binary format of the same class and how you would encode it in binary format. So again, you can see that the name of the class is in ASCII, and some of the properties you can identify in ASCII. And this will become important when we look at how we detect these attacks. So .NET also has this Ysoserial.NET gadgets. So I show on the right the list of those gadgets. They're composed of generators and formatters. Basically, you can take you're using a specific gadget chain, but you can format it in different format. You can use a SOAP formatter, or you can use a binary formatter and some other formatters. Formatters, they implement the AI format interface. So what is .NET remoting? It's a protocol of sending serialized instances. Parameters are passed to the method that is serialized, and the return value is serialized back in the response. It can be exploited through TCP and IPC and HTTP channels. And the binary formatter implements a secure mode, which through the type filter level property. So by setting this type filter level property to low, you can limit which classes you can serialize. But even with the low setting, there were gadgets that were identified that can exploit even this setting if this file is located in the product. But if its type filter level is set to full, then any object can be deserialized. So there's a way. This is a way to limit, to kind of prevent deserialization attacks. However, some products, and let's go into an example, such as a Rockwell automation FactoryTalk Diagnostics, have this type filter property set to full, and can lead to code execution. So this is a vulnerability that was discovered beginning of this year. It's a factory diagnostic system. It's a subsystem of factory view machine edition software package. It's a SCADA product. And FactoryTalk Diagnostics server is implemented as an executable, RNA Diagnostics srv.exe executable that is implemented in .NET and employs .NET remotely. So here I show, on the left, I show the onStart method of this executable. You can see the type filter level probably is actually explicitly set to full. And on the bottom, you can see that actual URL that's accepted. Basically, you're sending an this is exploited over HTTP channel. You're sending HTTP request, and it's expecting that the URL is sent to the URL has to be set to FactoryTalk log reader. And the sequence of classes that are executed, it's based on binary format, like I said. First, initially, the deserialization goes to binary server. The input is passed to binary server informator sync, which calls the core channel, and then eventually binary format deserialization, with the deserialization, insecure deserialization happens. So here I will show, again, a video of this exploitation. So I have a burp suite on the right. I have this post request, FactoryTalk log reader is the URL. The embedded is one of the Gadget Ysoserial.net Gadget chains. On the left, you can see that there is calc.exe is a spawn as a subprocess of RNA diagnostic server. So how do we detect these serialized attacks? As we can see that a lot of these even in binary format, you can look for the specific class name. So you can use blacklisting or whitelisting allowed classes. You basically prevent deserialization of specific libraries, deserialization in specific library chains. Or you can only accept this specific tag, whitelisting, which is only accept this specific class to be deserialized. Sorry, names of problematic classes are usually embedded in the payload as ASCII, but you might have to base 64 decode it, as we saw in XML RPC. Or in some cases, there's even the payload here is encrypted, which allows decryption. So that actually complicates the detection. You have to have the decryption key. But I show example of the Bing utils, common Bing utils exploitation. This Bing comparator, you can look for this string, and for the other one, vulnerabilities, you can look for those, like I said, the names of the class, the full name, including the package. Combining the looking for that specific class in the payload and also looking, for example, the URI, you can then detect these attacks on these products. So in the summary, many gadgets have been discovered in recent years. Other frameworks also are impacted, such as PHP. I actually worked on one of the Drupal. Drupal is an application framework widely used. It's based on PHP, and there was a authenticated deserialization attack was discovered in this product in the beginning of the last year, 2019. There's also some deserialization like Ruby on Rails. And recently, a lot of attacks on Oracle WebLogic, Incoherence package, Microsoft SharePoint, and I list some CVs for those vulnerabilities. So I think this is a type of attack that we'll see in the future as more and more web applications use this format. And that concludes my presentation. Thank you very much. And if you have any questions, I can answer them now.